The time is rapidly approaching where I am going to reinstall the Pixicon tube into the camera chassis. The next step is to reattach this capacitor that's down in this hole. It is soldered to the bottom of the main circuit board. That is the connection from the target ring, which is this brass piece you see from the side, and a resistor network that provides the DC bias to the target. You probably can't see it. There's a terminal strip with a resistor and a couple of capacitors to ground, forming a standard pi filter, bringing in the bias for the target connection, and then going from the target ring through the hole in the cabinet to the bottom side of the circuit board is a coupling capacitor. So that coupling capacitor needs to be reattached. First thing. The next step will be to reattach the mu metal shielding to the Pixicon tube. I roughly know where it was positioned. I believe the tube was like this, with this opening along the inside. This is the base connector for the tube that will go onto here. Note the absence of deflection coil and the absence of a focus coil. So those are the stages we'll have to go through to get the tube back in. And then I guess at that point we can turn things on and see what happens. Alrighty. Alright, well that appears to be where it goes. For now, I know it's not level. I know it's not level. I can see that it's not level. It's about 45 degrees. Alright. Connecting the collimator connecting pin on the side of the tube now. And apparently the target connection is just a brass clip that clips over the end of this glass, but I have no idea how it is coupled, if it's AC coupled or not. It can't be. Alright, so it's in. The tube is in place. Now comes the terrifying part. Al Denson thought that these, what were these? These were clamps for, these were off-the-shelf parts for clamping motors, I think, DC motors. Well, that's all well and good, but when this spring is attached to these metal plates down in here, the amount of force to get that thing to clip on is terrifying. I don't want to end up breaking the tube. So this is, okay, one side is on. Now, putting the other side on without crushing the tube is going to be amazing. Because these things are really tight, and they're steel. I need larger pliers. It's now or never, right? Oh, please don't break. I don't know how much farther I have to go to get that on. I know I had a heck of a time getting it off. Oh boy. I'm going to my plan B. I don't like these things. They're going to break the tube. This stuff makes great construction material. I don't know if you can see it. This is 22 gauge. First thing I do is I take the roll out of it. I make it as roughly straight into a rather large loop. Then I find the opposite end. And I twist them together. It caught the soldering iron cord. And what I'm doing now is splitting the entire roll in half. I've taken the wire now, doubled it and twisted it with the drill. And here we go. Okay, how do I want to do this? I need some up here. Like that. Oh, I see. It's gonna be like that, is it? A little bit more, huh? Well, this is the goofiest thing I've seen. It just slips over like that, apparently. There we go. The target is connected. The tube is connected. We have our lens, which is our next caveat. For one thing, the iris within the lens doesn't work. It's just sitting open at f8 perhaps. I'll have to hope for the best. With that, it seems to have a very interesting back focus capability to it also. Alright, so that's now in there. Next, test pattern. We need a test pattern. Well, I just happen to have one. This will be the test pattern that I use with this camera. I took The slide from a B&K television analyst. It's a acetate slide with the test pattern printed on it. And an old LCD backlight for a small 5-inch LCD. And bolted the two together. Why won't you focus? And made my own test pattern. It doesn't bite me. This operates at high voltage. You can see the little high voltage power supply on the back. That operates one small fluorescent tube in the top edge of the panel, and then a diffuser spreads the light evenly and flat. Perfect for lighting up a test pattern. We've got power. I don't see anything on the oscilloscope yet. Oh, here we go. There are pulses. We have horizontal sync coming out of this Pixicam camera, and if I slow down enough, you can see occasionally a vertical sync in there. We at 20 milliseconds. Back up to 5. If we untrigger, you should be able to see the vertical in there. There he is. You see it pulsing through there. So it's making pulses. The next step is to start turning up the... And by the way, there's noise on the screen. The the video amplifier is working. Well, I don't know what to tell you. After messing with the controls for a few moments, all I could do was manage to get a fuzzy image of the test pattern. The camera tube is good. The camera circuits are working. It's outputting video. It's making a really bad image at the moment, but I have a lot of variables to play with. So, absolutely amazing. It's working. Oh, by the way, all of the noise you see in the image there is caused by the backlight power supply. Well, it works. Alright, well, I'm going to keep messing with the controls. I hope I don't get my head in the picture. Flip the viewfinder so I can see. Okay. So, test pattern is lit up. There's my finger. Alright. Beam. Focus. No, target. I think this is collimator. Also, optical focus is not right either. Oh my goodness. Oh my goodness. You're kidding. That's target. Oh. Target voltage. Beam. I have a lot of beam. Oh. believe is the focus. No, that's the collimator. Okay. Beam focus. Collimator. Optical focus. That's too much interference. Wow. And surprisingly, the picture's right side up and reasonably level. I don't want to get my fingers under the chassis here. I'm trying to make it tilt down a little more. Astigmatism. This is the astigmatism control. This is horizontal centering. Alright, it looks good. Vertical centering. These are the pots I cleaned. They're behaving very nicely. There's width. Alright. Height. Centering. That's funny. Alright, we can see spots and stuff on the surface. There's very faint motion. I need a lot of light. I don't have a spotlight over here. There we go. I'm putting light onto the test pattern now, externally with an incandescent bulb. Hi! So, yeah. Now, turn this on. Well, vertical center, I want more height. I don't think it's going to get better than that. Not sure. Perhaps if I get a good lens. We lost the image. Oh, way too much beam. Target. Very slow to respond to the target voltage. Collimator. Beam focus. There's my fingers. It sees my hand just fine. There's my thumb. Okay, that's not the greatest camera in the world, but it's working. Who'd have thunk? Switching off test pattern light. Well, in the spirit of Halloween, which is a few days off, enjoy this image. This is my previous lab assistant. He came to an unfortunate crystal radio, and it was very unfortunate. Who knew those things could be dangerous?